Okay, other hands are raised. Who again raise his hand? So this is the interface of the software. As I said, the software is a free software. You can go online. You can go online and download them. Somebody say, I don't have access to the training materials. I've shared this thing. Engineer Shitu, your colleagues, I shared it with everybody yesterday. Your colleagues won't have it. You have collected it from them so that we can progress. I've shared the material. I'll share it again. I've shared it before. You were here yesterday. I shared it. I'm sure I shared to everybody. I said people should chat me up after the class and we'll share it. So the first thing you do, just like in every software, when you open any software you want to use, you have to go to the defaults and customize it. So here I go to default. I will set up this parameter. So you can open your software. You can open the software and set your parameters. You can say n should answer n. You can put anything you want. Under properties, I will set up these properties. Pipe length 1,000 feet because the unit is in.
Sorry for interrupting you like this.
Okay.
But to be honest, I don't think we're getting anywhere if you not explain, like for example, the ID labels, all these things you type in. If you don't understand what they mean,
okay,
or why is there 1 or why is there 40, I don't think anybody will be able to use anything.
Okay, I'll do that. Now, if you open the software, these are the toolbars. Let me start from the toolbars. This one is to label your object. This one is the valve. This is to put a pump. This is to add a pipe. Just each of them, you don't understand what they mean. Just hover around them, you get the name. This is a reservoir. This is a tank. This is a junction. A junction is like a manhole, as I said. This is the junction between two sections. Yesterday, we were talking about node 13, node 6. So node 6 is a node, node 13 is a node. So when you want to put a node, this is where you now add it. Then, and so on and so forth. So the first thing I do is I go to my project, I go to my default. Now I will say junction will be represented by N. Junction is like a manhole. It's like a place where the elevation values are known. It's like a place where water demand is known. Okay, in real life, that is where they will install a water pump, a water meter, sorry. Reservoir, as we all know, reservoir is where the water is coming from, the water source, okay, where the intake structure is. From the reservoir to the treatment plant to the upper storage tank back to the consumers. Then the tank is the elevated tank, or the TK, call it TK. Then the pipe represented by P. The pump represented by P. I can also say that the valves represented by V. Okay, and so on and so forth. Then ID increment will be 1. Why? Because after P1, the next will be P2, P3, P4. So it will be increasing by a factor of 1. So I've done with this. I'll go to the next tab. The next tab here is called property. The next tab is what? Property. Under property, I will set the defaults. Now, let me say this. These defaults are just like default values. It does not mean you will not change them. It's just for me to say, okay, this is what I want them to be at this point. So for instance, this is pipe diameter. If peradventure I forgot to include the size of any pipe, I want the body to, the software to assume 6 inches. I can change it to 4 inches and press enter. Whenever you input any value, you press enter. Now, what is the pipe roughness? It is 130 because I'm going to be using Williams. There's a small tutorial we're going to do before we do some other thing. And that tutorial is calibrated is using American units. American units is imperial. Americans talk about feet, inches. Williams roughness, but they are all the same thing. Then the flow units, I'll go to the hydraulics. You open here, you choose your flow units. All the flow units are here. Look at liter per seconds, liters per minute, milliliter per day, cubic meter per hour, cubic meter per day. So they are all here. This is cubic feet per second. So, but the tutorial I want to do now, we'll do with imperial units. I know what I'm doing. I'm doing it so that we can be on the same page. Head loss formula, I open it. We have 3 head loss formulas: Hezin-William formula, Dashi-Weisbach formula, and Chesi-Manning formula. If you go to your Google and you said, this is my Google, and I say, what is the frictional factor or roughness factor for PVC pipes? Let me see what it gives me. It's giving me this in meters. This is Dashi-Weisbach. So I can come here and say Hezin-William. Hezin-William. Yeah, look at it. See that frictional factor for PVC pipe in Hezin-Williams, and it says 150. Smooth pipes 140. Can you see my screen? Steel new online 140 to 150. Steel corrugated 60. So if you remember our fluid mechanics, frictional factor can be Dashi-Weisbach, Hezin-William, or Chesi-Manning. So whichever one you are using, you put the appropriate value. So here it says 150. So I can come here now and choose 150 as my Hezin-William formula. So I'll go back to properties. Under roughness, I'll change it to 150. Enter. Because here I'm using Hezin-Williams. If I'm using Dashi-Weisbach, it will be 0.1 or 0.4 or 1.0, depending on the pipe material we are using. Then here, the maximum trial, the accuracy, I want my value to be to the nearest 0.1. I can go down. Every other value, I'll leave it as default. Whenever I have need to change them, I will come back and change them. Specific gravity is 1. Relative viscosity is 1. Because we are using water. Water is 111. Number of iteration, 40 times. Leave it at default. Properties. For every segment of pipe that I put, it should be 100 feet. Auto length is off. It means I'm going to put the values of the pipe myself. I'm going to put them in individually. That's what this means. The default pipe diameter is 4 inches. As I said, we'll be doing imperial. Why? Because there's a tutorial in our material that I want us to first do. So go back to your material. You go to workshop files and data. You will see Epanet exercise 1. Open it with Adobe. Epanet exercise 1. So look at this network. This is a simple network. We're going to use it. Why I'm using this network is because we all have the tutorial, and from there, if you miss anything, you can follow. In this tutorial, we analyze the simple diffusion network shown below. It consists of a water source. This is it. Example, a treatment plant, clear well, from which water is pumped into a two-looped pipe network. There's also a pipe leading to a storage tank that floats on the system here. Now, let me say this. This is not a normal system. A normal system should be that the tank is somewhere here. From the reservoir, we pump to the tank, then from the tank to this place. But let's just do this. The next one we'll do how it should be, just like we did yesterday. There should be upper reservoir supplying water, and not the same pump, the same pipe that is supplying water to the network, also supplying the tank. So what they just did here is that this same line will supply water to the tank. And when the tank is full,
hello, we can see that screen. No, is you that we're seeing?
refresh your screen, you see it. Who is speaking, please? Okay, Aziz. Yeah. So now, refresh is from your end. Okay. Now, so this pipe is also supplying water to this tank. So the idea is what they do is most states, even in Abuja. Now look at the idea. The idea is that when there's no water, when you're pumping water, these people will have their own tanks, overhead tanks. So water will fill their whole overhead tank and also fill the main tank. Then you stop your pump. When their water level goes down, water will flow from this overhead tank back into their system. Okay? But ideally, this is what most network look like. Most network will be this way. You have your water source here. You pump water to the reservoir. Then these are your catchments. These are your catchments. So from the upper reservoir, this is your reservoir or tank, and this is your source. So from here, water will now flow through here, branching off to the different catchments. This is the normal arrangement. But sometimes you can also put it such a way that water will pump here, and after these tanks are full, the water will now fill the reservoir also. Then when you stop your pump, the water will flow back into the system. Is that understood? I hope so. Now, I'm going to draw this network. So here, all what
please, where's this material? Sorry, sir.
Okay, yeah, the material is in under workshop files and data. You go to Epanet exercise 1. This is your folder. You go to workshop files and data. Then you go to exercise 1. You right click and open with Adobe.
Yeah, I've seen it. I've seen it, sir.
Okay.
Thank you,
sir. Thank you, sir. So I'm done with this. Then I can also go back to projects, summary, nothing there. View, dimensions. If I'm drawing in meters, I put it in meter. If I'm not doing in meter, I put it in feet. So this one, I'll put it in feet because I'm using American units. I will say, okay. So that is my default. I'll set up my defaults. Now the next thing is I'm going to draw my network. So what am I going to draw? I'm going to draw exactly what we have here. So I'm going to draw it, and I want you to master it now. Now, you can see that this network have labels. It has labels. So if I want the labels to show, if I want these labels to show, as you have them here, I have to go and activate it. So I'll go to view. Take note of this, please, everybody. Take note of what I'm doing now. If I go to view, I go to options. Those of you that use AutoCAD, remember you have options in AutoCAD. O-snap, grid snap, right-click customization, aperture size, background color. There's always options. I go to options. Then I ask him to make the node say 5 in size. The link to be 2 in size. The labels, I'll leave it notation, I'll say display.
The options.
Yeah, under options, yeah. So that this is where you customize your view, how your things will look like. So under options, I'll ask my map to always display for me the link ID, the link value, the node ID, at least the first four. I can also go and change other things, but there's not much thing to change than background. I'm using a white background. I can try to use a black background or a gray background. It's all my choice. But when I'm done,
where are the options again? And it's
under view,
it's a bit,
view,
it's too far.
view, the last. Forgive me, I'm a bit
Why
fast
are we
because.
rushing? Why are we rushing this?
Okay. Okay. Under view, options. The good thing is that, of course, the video is being recorded, and also there are specialized videos in my YouTube channel. So go there, you will learn more after the class. Okay. So after setting my options, I'll click OK. I want you to open this thing while you watch on the screen. Let this file be open because I'm going to draw this and I'll try to do it very well. I'm going to draw this, not in any particular order. So the first thing I'll do, I'll pick my reservoir. I'll drop it. I'll click on this select two. When I'm done, I click on select two. So that even if I click anywhere, it will not drop. Because if I click on reservoir and drop it 2 times, it will drop to reservoir. And to delete, you just simply press delete on your keyboard. Highlight the object and press delete on your keyboard. The next thing, I'll put the first node here. Put the second node here. Why is it saying N1? Remember, I've gone here and say N. And furthermore, I say increment should be what? 1. So N1, N2, N3, because I've set it here. And why is it displaying? It's displaying because I've gone to view, options, and I said display node values. This is number 2. Display node values. So I press OK.
Yes. You're fast though.
Yes, I'm fast because we have 3 hours, but I will.
Yeah, but look, who can remember this? And if you don't even know why we're doing certain things, it's too fast.
Okay, I'll slow down.
Yeah, we are trying to follow you.
Oh, okay. Okay.
How do I delete?
Okay, yeah. To delete, you highlight it this way, then right click and say delete.
Okay.
Again, to delete, you can also click here. If you go to your data browser, it is telling me that I have 2 nodes, node 1 and node 2. I'll click on this symbol. Okay, now I understand. You guys are following me, so I'll take it slow and steady. And not just slow and steady. At some point, I'm going to pause the recording and give you 5 minutes to catch up. So I would like you to watch me do, then I give you 2 minutes to do. Is that okay?
Okay. Yes.
So after
that's cool.
Let me add the whole node. Then I'll give you time to add yours. Then I'll click here. I'll add a node here. I'll add another one. Not in any particular order. Don't mind the numbering. You can always change them. I will now drop it. It's not more there. I will now go and click tank. And I'll drop tank. Then this one, after dropping tank, I'll go and click select again. Please, once you execute any command, go and press this black arrow. It is deselecting. It's a way of deselecting. If not, you keep clicking, you keep adding. And remember, if you want to delete, just click on it. Like this one, I can right click on it now and say delete. I can also click on it, come here and press delete. If this is not well aligned, I can click on it, hold down my shift, my mouse, and drag. I didn't ask us people that will have mouse. You should have mouse for this. So can you have 1 minute to practice? This is 46. Can you go pick up this? This is your junction. And then add. If it's not displaying, don't worry. You just have to go to view, options, and then go to notation and make sure that the first 4 boxes are checked. If you are done, just type yes on the chat box for me, please. Just say yes, done. Just type done. Oh, 2 people are done.
Excuse me, I have a question. Why did we use gallons per minute and feet instead of liter per second and meter?
Thank you, sir. The reason is that this is a tutorial that came with the software. This tutorial is a sample tutorial with the software, and it is calibrated in American units. It's using American system. The next one we'll do, I will show us how to change it to liter per seconds, meters, and SI units. Okay. So for us to be on the same page and to get the same result, I usually use this to start. But to change that, sir, all you need to do is simply go to defaults, then go to hydraulics, make sure that this is changed to liters per seconds. And when it does, you come here and confirm. And if you are drawing to scale, you have to make sure that auto length is on. I'll still tell us about that one. So we're using American unit, but the concept is the same. So
and where's the change to feet? Sorry.
Here.
This one is liter per second, but where's the feet thing?
Then you go to here, view, dimensions, meters.
Okay, thanks.
So, okay, Engineer Chimana, you have a question. What I'm doing now is just to drag. I click down and drag.
I just wanted to find out on my practice, my pipe number 8 did not appear in this curve. It came like it's straight right angle.
You use vertex. I'll show you how to do it. You click on vertex and add vertices to it, and then you drag it. Okay, let me get there. Now let me check how many people have done this. We've not done much, sir. Engineer Hamid. Just open this software, click on reservoir, drop it here, click on node, drop here, click this, drop here, click this, drop here, get this shape. We've not done much. Just replicate what I've done. So far, that's what we've done.
Let me interrupt more. I wanted to know, I saw you trying to move around with your reservoir 1. You pick it, I tried to do the same thing, it wasn't. As in changing its position.
No, what I did was, I click and I held it down, I had my mouse down. Click and held down and then you drag.
Okay.
Click and hold down your mouse. You know how we normally drag. Hold down your mouse and drag it.
Yeah, I got it.
Okay. Now, the next thing is we're going to put our pipes. Now, the first pipe will be from here because from here to here is a pump. So from node 1, when you click this pipe, it turns to a pencil. Then if it does not end as a section, you are wrong. So when I click at the center of this one, it will turn to a plus. and it will give me pipe 1. If he continues, it's wrong. It has to end. Then I'll go and click this black arrow again to deselect. Okay, it must be end to end. So for instance, if I click on this pipe again, it will turn to a plus sign. When I click on the center of this, it will turn to a pencil. I'll click on the center, the pencil will disappear, and a line section will be created. If it does not do like that, then something is wrong. I'll click on this one, get here, and I'll click. I'll click on this one. Don't mind the lettering. I just want you to understand how it is done. Don't mind whether it's falling in line or not. You see this one? After clicking, it's still continuing. So I will press escape and start all over again. It has to end like a section. Please, after the training, I'm going to support this training with some videos, especially regarding the software. There are about 3 videos on YouTube, which I have done, that explains how to do some things about the software, which time might not permit us to cover. So I crave your indulgence. After the class, try and do what? Go through them. The next thing I'll do is I'll pick my pump. This is the pump. Everybody watch. Leave what you're doing and just watch. I click on the pump. It's active. The pump is from reservoir to the network. So I'll click on the reservoir and then click on the network. The pump will appear. And it will be written pump 1. Why? Because I have already set the default that the name of the pump should be pump and the ID increment should be 1. So it becomes pump 1. If I add another pump, it will be pump 2. If I add another one, it will be pump 3, and so on and so forth. So I'm giving you another 2 minutes to catch up with me. Put the pipes. Here are the pipes. For those who have lost Hamid Sheshitu, please go to your material, open this Epanet exercise 1. Epanet exercise 1, then this is tutorial. So everything we are doing have been enumerated here. Let me just tell you where we are. We've done this on the ID label page, clear all the ID prefixes and set the increments to 1. We've done this. We've done this. The view option, we've done it. So that is that. So 2 minutes, one more minute now. If you are done, please, this class should be interactive. You have to help me to help you. If you are done to this level only, just say yes. Say yes if you are done.
I'm having a problem with the lettering.
Okay, the lettering. If you are not seeing the lettering, what you do is you go to projects. No, you go to view, options, view. Under view, you go to options. Under options, you go to notation to annotate. The under notation, you check these 4 boxes. Make sure they are checked. And then you click OK. The lettering will show up.
Okay.
So I've drawn my network, I've drawn the pipes. The next thing I need to do is I have to impute the parameters now. Yesterday, I said there are 4 elements you need to design any network. 2 for the pipes, 2 for the nodes. So for the node, you need the elevation and the demand. You need to compute it in a tabular form. Remember, we had a table yesterday. Our table had 4 parameters. But now I'm calling out the first two. The other two are down here. The length and the diameter. So pipe 1 is this, pipe 2 is this, pipe 3 is this, just like we did yesterday. Okay, so these are the two for the node, and these are the two for the pipes. Two for node, two for pipes. Now, it is assumed that you have done your calculation, you have gotten the elevation from the surveyor, you have done your engineering design through water requirement per capita per day, safety factor, number of houses, and you came about this. It's assumed that you have done this and came about with these values. It's expected of you. Also, you have come about with this value here. The length, you have measured the length of each section, and then you have used the monogram to generate the diameter of each one. So this tutorial is done on the assumption that you have done what we did yesterday. Without what we did yesterday, you cannot do any modeling. This is the value you got yesterday that we're not going to use to do our model. So I'm going to key in these values into the model, these key values now. Node 1 elevation is this, demand is this, and so on and so forth. Are we together? Are we together?
Yes, sir.
Okay, thank you. So I'm going to do it arbitrarily. Only two elevations have changed here. The tank is at 850. While the system, the lowest in the system is 650. And the average, others are 700. And these are the pipe recommendation. You have designed the pipe from monogram, and you came out with this. So let us go. So let's start with the node now. So we're going to start with the node now.
We can't see your Epanet background yet.
Okay, here. So node 1, or no, okay, I'll click on this. I'll click back on select tools. So node 1.
Yeah, okay.
I'll double click on it, reservoir. Under the head, I'll put 700. Enter. Are you with me?
No, we are not.
Double click on the reservoir. The property will come out. Or you right click on it, long protocol, and it's a property. You can also go under here, click on reservoir, and then click on edit. The property will come out. Under total head,
You
put 700.
You click on the node 1, Abi.
Reservoir. Reservoir.
Did you click on the reservoir?
Yes, put 700 in.
Okay, you click on the double click.
Yeah, you double click or you right click, whichever one.
After pressing enter, the command is still there.
Yeah, you now close it.
Okay.
So I'm working based on this.
Responsive.
See, node 1, if you go to the drawing we're using, this is node 1. The node 1 is reservoir, and the elevation of reservoir is 700.
So you double click, and then under the total head, you put, man is saying not NA. Mine is showing NA.
Okay. This is reservoir, sir. But I click on it, you scroll up or down. You are somewhere here.
Yes. Yes,
Scroll
I'm
up,
seeing
sir.
this. This
Scroll up,
NA.
scroll up, scroll up, scroll up. Go to total head, total head. Go to total head. Total head.
Please, can we move on, please?
So, okay. We'll go to node 1. Node 1 elevation is 700. Base demand is 0. The base demand is 0. Base demand, the software will calculate total demand. Your job is to put in the base demand based on every node. Just the 2 parameters. You remember what I told us? For the node, you need 2 parameters. So for the node, this is 2 parameters. Node 2. Node 2 is about 710. And the base demand should be 150, I think. Okay, node 2 is 0, 710. My node 2 here is node 3 here. So it's 150. Here, I'll say 150. You with me? Enter. Just 2 values I'm changing. Elevation and demand. Remember, we are imputing only 4 parameters. 2 for the node, 2 for the pipes. So let's put in the 2 parameters for the nodes. And the 2 parameters for the nodes are just the elevation and the demand. So next, I'll come to node 4, 700 and 150. Node 4 is somewhere here. Mine is saying 3, but I know it's 4. 150, base demand, 700. Enter. Enter. So node 4, this node 4, the elevation is 650. And the demand, let me check. 650 is 200. The demand is 200. Enter. So what I'm doing is that I'm keying in these values. I'm keying in these values based on this. You can see this is 2, this is 3. So my 3 is my 2. So just put it for the idea is for you to get how it is done. Yours might be different. Yours might be 10, 11, or whatever, but try to see which one falls in here. This is 2, this is 1. So 1 represents reservoir. After putting the 2 value for the node, we'll put the 2 value for the pipes, design our pump, design our tank, case is closed. 2 value for the node, 2 value for the length for the pipe. Then we'll design our tank with the value, the elevation values of the tank, design our reservoir. Okay, design reservoir is only the head, the total head for reservoir. Then for the pump, we design a pump curve with the demand and then run our system. And that will be end. It's very simple software. It's just for you to understand how it is used. So the next thing is we go to this one. This one should be 700 or so, and I think 150 or so. Go to this one, 700. It's almost like a flat line, 200, 250, or whatever it is. It's almost like a flat line. So I've designed this. I've designed this. These are the 2 values. I've designed these 2 values. I've designed these 2 values. Design these 2 values. Assign these two values. Assign these two values. So I've imputed the value for the nodes, which is here, which is exactly what we did yesterday, remember? Remember our Excel sheet yesterday? It has 4 parameters. So, and my job is to put in those 4 parameters. So these are the 2 parameters. So far I'm working with elevation and demand. That is what I need to impute into the nodes. When I'm done, I'll move over to the pipes. And for the pipes, I'm going to impute this and this. Okay, so let me come here and say pipe, node. So that's exactly what you have here for the node properties. Next, we move to the pipe properties. Pipe 1 is 3,000 feet. Diameter is 14 inches. This is my pipe 1. I'll double click on it. Now you can see that it is written 1,000. Why is this 1,000? Because when I started the software, I went to project, went to default, under properties, I said the length of every pipe should be what? 1,000. And auto length should be off. It means that all of them will assume 1,000, irrespective of their normal length. But later I will show you how auto length will be on. Then you'll be capturing the normal length the way it is. Okay, so let's start with pipe 1. Pipe 1, the 14 inches and 3,000 feet. The roughness is 150, so it's there by default. I've designed pipe 1. I'll go back to pipe 2. Pipe 2 is 5,000 feet and it is 12 inches. And that is pipe 2 here. Pipe 2. Here is using pipe 4. If I want to change it, I know how to change it. I'll show you later. The length is 5,000. The 12. Can somebody explain to me why here is 14 and here is 12? Can somebody just explain to me why here is 12, here is 14? You can see that this place is 2, here is 4. If I want to change it, I will click on this one, come up here. This is P4. I will try to change it to P2, but it will tell me somebody's answering P2. So what I'll do, I'll change it to say PA. Let me leave it. Sorry, let me not confuse us with it. I'll come here. Change this one to 4. I'll now go back, click on this one. Change it to 2. So here, I'll come here. This is P3 is, as I said, this is P3, this is P4, but it doesn't matter. It just simply doesn't matter. The whole idea is for you to grasp how to do it. So I won't be going back and forth. I'll just be imputing this. So P3 is 8 inches, 8 inches. The next one that is 10 inches is P6. And P6 is in the direction of the main tank. In the direction of the main tank. So let me go here. So this one now is P, 10 inches already. It's about 7,000. That's P6. So here should be P6. But if I try to put P6, it will question me that somebody is bearing P. It will even allow me until I get to P6. Make sure I change P6 to something. And I can now come back here, change it to P6.
You wrote 700 length, not 7,000.
Oh, thank you. 7,000 feet, because we are drawing in imperial. So
excuse me. How can I say change the numbering of the pipes or not? If I, for example, I mean, I'm with you on the values. I understand the principle, but just if I want to change to be in line with your drawing.
Okay,
watch
me
maybe
now.
With the drawing from the exercise.
Yeah. Now, what you do is, like here, I want to change this to 3 and this to 4. But if I change this to 3, it won't allow me because somebody's answering 3 already. So what I need to do first is to click on this pipe 3. I'll change it to say A or anything. Okay. Then I'll now come now and click on this one and change it to P3. And then go back to this one and change it to P4. Just try your hand on it. Now,
thanks.
Okay, I can also change this now to say, assuming I don't want it to answer P. I click on it and say this is answer Uche. Pipe Uche. Just for me to draw emphasis. I can also answer this one, click on this one, and I'll change it to say Hamburg Road. Hamburg. I love Hamburg. I've been to Hamburg. Hamburg Harbor. So it's flexible. So, I mean, this is just telling you this is the pipeline going from the North Sea to Hamburg, maybe, and so on and so forth. So it's flexible. But the thing is, if another number is bearing that name, then you have first of all have to create a dummy and then change it. So let me go back here. Originally it is answering 8. So let me go back and change it to 8. Under property 8. Okay, so I'm here. I've done this. I'll come here. I'll change this to 5,000, I think, and 8 inches. I'll come to this one. I think is 6,000. Can help me check. 8 inches. Or is this 6 inches? Let me check which one is 6 inches. One is 6 inches. So number 7 and number 8 are 6 inches. So where are they located? This is number 7 and number 8. So I'm in error. So this is 6. Can somebody tell me why it's 6 inches? Because it's at the lowest end. It's at the lowest end. So 6. Here, the pipe size here is 14 inches. But as soon as it goes into the network, the remaining one going to the tank reduced to 12 inches. And as soon as it gets here, it releases some load or it discharges enough water. It quickly changes to 10. So that's one concept I want us to understand. As your pipe network is going, as it's giving out water to consumers, it's also reducing in value. Is that okay? Okay, so let's continue. So this is the 4. So I can go back and change this back to 4. So I think I've designed all my pipes. Okay, no, not this one. This one is 8 and it's about 5,000 feet. Here I've designed this one. It's 10, 7,000. So you can see that all the pipe now has 2 values in them. Just confirm. Okay, I think this one hasn't has anything. 8 and
excuse me, is there a view where I can see all pipes and all knots I draw it? And so basically can on a quick look I can see if I maybe missed something to add.
Okay, go to table. Go to table here. Click on table. When you click on table, you say link. Then under link, you say okay. These are the whole tables. I do it again. You see all your tables in a glance. You go to link. You click on link. There are 2. You click OK. Tell you the length, the diameter, the roughness, the bulk. And if I want to remove all this one, if I want to filter all this, then when I click on this table, I have to go to filter column. I will dictate what I want. I want to see the elevation. I want to see the properties I want to see. I will highlight them here. If I want to see many properties here, I will say okay to give me a lot of them, but all of them have not been designed. These pipe have not been designed, so all of these ones will be not available, not available. But when I run my model, they will have values. So far, they don't have values because I've not run my model. Is that okay? Okay, so I'll give you 2 minutes again for you to input all the values. Please, we are running out of time. Can we all input all the values? And when you are done, say done. So for me, I am done. So I'm the first person that is done. So if I get 5 people who say they are done, we'll continue the class. Okay, I've gotten 1. Those who have not done, just do it. Just click and check 2 values, length, diameter. Make sure it's in all, please. It's important that you put the length and the diameter, which you have designed from here, which you must have done based on what we did yesterday. I love how we did this training. These trainings have been sequential. The first day we laid the foundation, we made a presentation, we gave you the summary. The second day, we did a case study, a first principle design, manual design, how it should be. Then this last day, we are now using what we learned yesterday to model our network or system. So even if you cannot use this computer, what we did yesterday is what everybody is doing so far. Computer modeling is just to model and to simulate, to add extra value, to show, to kind of authenticate what you are doing, to give it some kind of validation. That's what this software is doing. Epanet does not do your design. Epanet only models your design for you. I have not seen any response except from one person.
I'm confused about it's confusing. This point is confusing.
Sir, if you double click on the pipe, you put a value for the length and for the node. You don't need to be exact. Just put between 5,000 or 6,000 feet and then put diameter between these are diameters. These 3 that are huge are the ones in the direction of the overhead tank. They are big because they need to supply water to the overhead tank in record time. I think somebody mentioned this yesterday. The pipe your transmission pipe is usually huge, it's big, because it's the one that will transmit water from your reservoir to the upper tank. So you don't need it to transmit this water all day. You have to transmit this water within 1 or 2 hours. So the pipe size will be big. If assuming you are the pipe size you're using in your network is 3 inches, then the pipe going to your overhead tank should be like 5 or 6 inches. So that within, and then the pump should be commensurable. All these things have to be designed anyway. Okay, it has to be designed depending on how many hours you are pumping and the capacity of the pump. The capacity of the pump, the head and the discharge. Every pump is defined by 2 things, the head and the discharge. The head and the discharge. The higher the head, the lower the discharge. The lower the head, the higher the discharge. So you should be able to look at what you have in your network and know which one you have more. And make sure that those 2 are all met. Okay. Only 1 person so far. That's not too good. Except some of us are using our laptop.
If it's laptop, it will be easier.
Okay, you're not using laptop?
No.
Oh, you'd have said it. There's no way you can do this with your computer, please.
So I'm not. It's now that I'm using I've opened the laptop.
Okay. Now, let's continue, please. Okay, let me check how many people now. Okay, the number is good. Number is good. Okay, Aminchi Joshua, I've done it. Uyi Balon, Lucy, have done it. Robert, have done it. Balogban, have done it. Okay, 1, 2, 3, 4, 5. Elijah, have done it. Okay. I don't expect everyone to do it. Some people will do it later. Some people have grasped it. Some people are going to watch the video. So we're good to go. So let me design my pump.
18 participants, 18 people there.
So I'm going to design my pump.
And this thing will be left. They said before, but
so I'm going to design my pump now. So which one did I design first? If you missed any of this thing, like the one I'm doing now, if you missed anything now, go to page. We're on page 5 now. Page 5 say adding a pump. So if you miss anything I've said now, go to page 5 and read on adding a pump curve. It says select the pump curve onto the property editor. Enter the ID label 1 in the pump curve field. Create pump curve 1 from the data page of the browser. Select curves from the drop-down list button. Then click the add button. Now this is confusing, but if peradventure you missed it, go here and you learn it. But one thing I want to draw attention to is say, enter the pump design flow as 600 and head as 150 into this form. Take note of the word, head 150. The flow 600. It says Epanet will automatically create a complete pump curve from this single point. The pump curve equation is shown with each shape. Click OK on the dialog box to assemble the pump curve. Now, we are engineers. Every pump requires a pump curve to run. When a manufacturer produces a pump, he calibrates it based on pump curve, which my colleague taught us on the first day. The pump curve will tell you the best operating point of the curve in terms of the efficiency, in terms of the flow, in terms of the head. If you remember our university days, we all did it, engine 202 or whatever, fluid mechanics, a pump curve. So what we're going to do now, we're going to create a pump curve and call it, give it ID 1. Then we'll now go to our pump curve and edit it and tell him to run the pump with pump curve 1. So this time around, follow me and let me do it. So now I'll go to data browser, look my data browser. Under this data browser, I'll open this flyout. When I open this flyout, I'll go to curves. Curves. When I go
So
to
we
curves,
cannot see it.
so I'll go to my data browser. When I go to data browser, I'll open it like this. I'll go to curves. When I click on curves, everywhere is blank. But there's an icon here called add. Hover around it. When I mean hover, I mean place your mouse on it. It will tell you the name. That's the window-based operation. I'll click on this add. It will automatically open a dialog box. And here, it will say curve ID 1. I'll come under flow. I'll put in 600. I'll come under head. I'll put in 150. And I will say, I'll click on anywhere. It will draw a pump curve. This pump curve means that at a discharge of 150, the maximum head will be 150. And a discharge of 600. It means at a discharge of 0, it can deliver a head of 200. And if I want the head, if I want this pump to deliver at, say, here, 750, the head will be around 120. Anybody that understands the activity of pump, you know that pump has optimal point, and that optimal point is somewhere here where the discharge and the flow is at the best efficient of the curve. If you didn't operate this pump at its best efficiency, the pump will have problem. So here we have created a pump curve. Why are we saying 150? So I'll click OK. 150 because the minimum elevation in our network is 700, which is the elevation of the reservoir. And the maximum elevation in our network is 830, which is the elevation of the storage tank. So if you now say 830 minus 700, you're going to get 130. This 130 is the elevation difference. And that is the head that a pump needs to overcome for it to be able to push water from the reservoir, which is at 700, to the upper reservoir or tank or the elevated tank at 830. So you need a pump that has a minimum head of 130, but we decided to use 150 because there are losses. So the other 20 extra is to take over to take care of the losses. I'll click OK. So what I did was I went to here, data browser, I went to curves. When I went to curves, I click on add new. And I put here 600. And I put here 150. And when I click outside,
But
draw the curve.
This 600 flow,
yeah,
is again, is it liter per second now or gallons per minute? Or
it's gallon per minute, sir. Everything we are doing is in American units. So the flow is in gallons per minute. The length is in feet. That's American for you. Then the pipe diameter is in inches.
slightly confusing. But okay.
Just assume it's American standard unit. So if we are doing imperial, the flow will be liters per seconds. The length will be meters. Diameter will be millimeter. No, millimeter. No, millimeter. Okay, let me put it this way. Okay, for imperial, okay, for imperial, their flow is in gallons per minute. Pipe length is in feet. Diameter, pipe diameter is in inches. Then in SI units, the flow will be liter per second. The pipe, meters. The diameter, millimeters.
And this pump parameters of flow and head, did we, I mean, we have not dimensioned a pump before. So we just took it now randomly, more or less, or this,
what we did for the pump, if you look at your network, in my network, the elevation of the reservoir is 700, and the elevation of the upper reservoir of the highest point, which is the position of the elevated tank, is 830. Oh, we didn't design it. 830. We didn't design our tank. I'll come back and design it. Sorry, I'm coming back to design my tank. The elevation is 830. From here, on this table, here, this is the tank. 0.8 is the tank, 830. So in a network, to design your pump, you ask yourself, from point A, I'm pumping water from point A to point B. What is the elevation of point A? 700. What is the elevation of point B, where the water is going? 830. So the elevation difference is 700. So let me be putting it down. Sorry. So the reservoir is at elevation of 700 meters above sea level. Meters water column, whatever. The tank is at, Elijah, I'm coming, 830 meter water column, or MOCL, can also be in MOCL, meters above sea level. Okay, it can be anyone. It can be anyone, no need for that. You understand what I mean. Therefore, it means that the head that the pump need to overcome, any pump that we're designing, has to overcome a head of 830 minus 700. And that will give you 130. So, but I cannot go to the market and say, give me a 130 head pump. That will make me an unengineer. An engineer should know that we have head losses due to the pipe. This one is this head loss. Head loss is just 130. But there are pipe losses. Pipe losses. Oh, we did this yesterday. I'm sure. Remember our formula? Losses in a pipe is V square. There's a loss due to loss due to potential, loss due to frictional factor from the pipe. This is the who has this formula again? Who is this scientist? Euler, Langerian? No. Somebody in table dynamics. Bernoulli. This is Bernoulli equation. This is from Bernoulli. You know, when you talk about pipe, a reference scientist in pipe is Bernoulli. Bernoulli is number one. I don't know where he's from, but I'm using his formula. Okay, so Robert, this is how we came about 130. So I now go to the market, I say, give me a 150 head pump. I'm assuming that 20 meter or 2 bars, 20 meter, we go for these 2 losses. So these losses have taken care of MGH.
So basically, for this exercise, we did not dimension the pump. We just assumed the head losses are 20 and added them.
Yes, we added
okay,
extra.
it's okay.
Yeah.
Just
Now,
thought I missed a step here.
Okay. Now, if you run it, if it is not delivering water, Epanet will tell you. That's a good thing. That's why some people say Epanet helps you to dimension your pump. Actually, Epanet helps you to check your pump. And if you agree with me, checking something and dimensioning is just similar. If you throw something at you and it doesn't like it, it will tell you, no, this doesn't like. So what you do, you iterate. Okay, somebody is raising a hand. How do you navigate to data page to select the pump curve? Okay.
I was raising my hand because, can I ask now, or you want to answer this other question first?
Let me answer this question, then you answer. Go to your data browser, go to curves. Click on curves and click on add. And then you put your head, which you have designed. Now Epanet will help you check. And the flow 600. If you go to the markets, I have known this. If you buy a pump, on the body of the pump, it will be written head flow, head flow, head flow. So if you say you want a pump head of 150, it does not mean it cannot work at 50 head. It can even work at 200 head, but the flow will reduce. But they also indicate you, tell you the best operating efficiency. Mechanical engineers will know this better. Okay, so when I go here, I will now click anywhere, it will draw the pump curve. I'll say, okay. So before you ask a question, now when I did this, it gave me a pump curve of 1. So I will now go and double click on this pump. Here you see pump curve, it is blank. I will put 1. So this 1 is like a file reference. I'm not telling him that I've created a pump curve. If you want to run, please, using pump curve, run with the pump curve I've created. And this is my pump curve. And if I edit it, this is it. It's pairing ID curve 1. So I'll come to my pump, double click on it, and make sure I put 1 here and press enter. If you are designing your pump based on power, you put it here. If you are designing your pump based on the speed of the pump, you put it here. But I can tell you, the pump curve is the most acceptable way of defining the pump. Enter. So Elijah, I can ask a question now.
I was looking at my Epanet page, that is on the app. When I click on the node, I see elevation. I see elevation also for tank and all of that. But when I click on the reservoir, in place of elevation, I see total head. Is that what I should use?
Yes, because reservoir is defined by the total head.
Okay, so that's just a little. Thank you.
Okay, thank you. Okay, any other question? Engineer Akisole, you've been battling to join. Not to worry, just follow. After the class, I will attend to you. I will send you the whole videos and much more, please. Just chat me on WhatsApp after the class. I'll send you the whole videos. Okay, so I've defined my pump. Now, make sure you design, some of us didn't design our tank. To design your tank, please go to page 4. Page 4, second paragraph, third paragraph, sorry. You see, just like what Elijah asked me, he said reservoir 1, enter 700 in the total headed field. For the tank, enter 830 for each elevation, 4 for each initial value, 20 for each maximum value, and 60 for each diameter. So this is also a way of designing tank. Why we put initial value here is that we are saying freeboard. We are saying I'm assuming a reference of 4 meters. So at 4 meters water in my tank is designed. If the water goes to 20 meters, that will be surplus to requirements. So the maximum level that the water can go in the tank is 20 meters. And the minimum level is, the minimum level can be 0, but the initial level is 4. So you go to your Epanet, you double click on the tank and make sure that elevation is 30, initial level is 4, maximum level can be 0. No, maximum level should be 1. It's not good for the pump to be at 0 level. So you can just put it at 1. Okay, so
anything for minimum volume, sorry, anything for minimum volume.
Minimum volume, where?
Under
minimum
the
level
diameter.
1. No.
So we have
that
initial level.
That would be using a different model to define your tank. So leave it. We are just using the levels. Okay, we have designed the diameter, and we have told him the initial level, the minimum level, the maximum level, and that's okay.
So initial level is 1, minimum level is 4, maximum level is 20, diameter is 60.
Exactly.
Elevation 830.
Yeah.
Thank you.
Okay.
Hello.
Yes, sir.
What was those this mixing model, this LIFO, FIFO, 2 comp? What does it mean?
Where? Under where?
Under that tank property.
Tank property. Oh, no, I don't know what I mean. Sorry. Just leave it at default. There's a mixing level, you know, these are advanced things beyond what we're doing. If you have 2 types of water, if you're getting water from surface tank and groundwater with different property, different deptability, and if you want to achieve a certain parameter, you can decide to mix 20-60, 80-20. So these are different things. So these are like somebody who is modeling quality. If you want to model water quality, you make use of those parameters. Remember, Epanet is something you can also use in the academia to do water quality modeling. The procedure is in the manual I've sent to you. But for me, I've limited myself to the one that I know that I can use to get my work done as a consultant, and not like a professor. So professors can use it and do it.
Post house.
Sorry? Another hand is raised. Another hand is raised. We're not modeling the quality of the water. We're assuming that the water is treated, is clean.
Why is our diameter 60 sorry for jumping in for the tank? Why is our diameter 60?
Can you explain the tank
60
again, please?
Sorry?
Why is it 60?
Sir.
2 questions at the same time. Well, let me answer first. Well, it is assumed that you must have designed, you know, yesterday we talked about how to design tank. When you design your tank finish, if you're using a cylindrical tank is pi r square h. Okay. I don't know if you understand what I mean. Normal way of designing a tank. So you must have designed your tank and come up with a diameter. Remember what we are doing here. That's why I said this software does not design. It's assumed that we have done our design.
I guess it's a fee.
Are you with me?
I'm with you.
Yeah. Diameter tanks are designed based on if it's cylindrical type, then it should have a diameter.
Okay. So typically in practice, I would normally use a rectangular tank. So how will diameter apply in this case?
A rectangular tank.
I'll use it in practice. I'll use a rectangular tank.
What is the volume for rectangle?
Rectangle, length, breadth, height.
Because there's a way you can compute your rectangle. Your height will become your okay, the height becomes the 20. I don't know if you understand here.
Okay, length, breadth, height, yeah.
And then the diameter becomes the width.
Okay.
Yeah. What you just do is you equate diameter with a cylindrical with the rectangular. Tanks are designed based on their volume. I don't know if I understand. So irrespective of whether you're using rectangle, or any other shape, it is equal to the volume. Then you now design the parameters.
Well, my question is, for the tank, the particulars are the things confusing me: elevation, initial level, minimum level. I don't know if you can go over them again, please.
Okay, this is what I understand by it. If I drew a tank now, this is my tank. Okay. And this tank has a, let's say it has a length of 25 meters high, cylindrical.
Yeah.
So I say the water should not go below 4 meters.
Okay.
Should not go above, like the tank they have in Abuja, 20 meters.
Okay.
So I'm giving like a 3-meter freeboard.
Okay, I understand now.
Okay.
It's clear.
Okay. The whole idea is to know, is an added height. I don't know how to say. If I'm this 20 now, remember what we did on the first day? Pressure zone. So this 20 now is the height, is an added height, is an added value for the pressure. In Abuja, for instance, let me share this with you. The water that's supplying at Gwarimpa, if it gets to a certain level, some areas in Gwarimpa will not see water. Because the tank they are using now to supply Gwarimpa is not the tank that is meant for Gwarimpa. The tank that is meant for Gwarimpa is not, it's being built. Some of us that live in Abuja, you see that there are some, I think they are trying to resume work on the tank that was supposed to supply Gwarimpa. So they are using a tank that is meant for another district. So that tank is not too high enough. So each time the water level goes down to a certain level, people will have water stress. In some area, the pressure in water in some areas in Gwarimpa will be abysmal.
So what is the implication of the initial level?
The initial level is that you need to, after you have done your pressure zoning and you determine your minimum pressure level, that will now give you the height of your reservoir. And now if you are now buying your tank, you will not make sure that your tank, the height of your reservoir is taking the reference from the bottom of the tank. So that everything inside the tank will now be, whether the water fluctuates in the tank, it will not affect the pressure in the system. Let's focus on the software. I will have had time to explain it more. So now, what have we done? We have designed a pump. We have designed the reservoir. We have designed the tank. We have designed our nodes with the 2 parameters. We have designed our pipe with the 2 parameters. So we are done. The next thing we do is we go and run our model. So under projects, you say run analysis. Or you come here, you click on this icon. Whichever one, they're all the same. So here, projects, run analysis. Or you come to the standard toolbar, run. So I'm going to run mine now. Mine is successful.
I don't know if I'm alone, but I'm only seeing your whiteboard.
Refresh. I've left the whiteboard.
I think you're alone.
Okay. So go to project and click run analysis. Some of you, your own will be successful. But the good news is it will tell you where the unsuccessfulness is coming. It will tell you where
I have an error. Invalid lower upper levels for tank.
Okay, so you go back to the tank, double click on your tank and design your tank very well. This is my tank. The good thing about the software is that if you make any mistake, it will give you a feedback, a report, indicating where the mistake has been made.
Yeah.
Are we there?
Lion is not running too.
Mine didn't run because of the pump.
Okay, now go back to the pump. When you click on the pump, make sure that you have 1 here. And check the direction of the pump.
Yeah.
Then the second thing, go here and go to your curve. And make sure you have defined your pump curve.
Huh?
If 150 is not here, anything less than 150 here will not run. Okay, I have two successful.
Hello.
Yes, I did. Two people are successful.
Please.
Hello. Some of you, your mistake would be that some nodes are reading 0. If your node is reading 0, it means that this pump cannot deliver water to that node. So you have to go and change the node to the appropriate value. Node 4 is 650, 200. If your node is, if any of your node is 0, you have a problem.
What's the base demand of the reservoir and base demand of the tank?
The reservoir does not have base demand. Reservoir has only total elevation, 700.
Okay. What about
Prince,
tank?
Prince is successful.
Tank has a base demand.
Is 830. No,
base
tank
demand.
cannot have base demand.
Okay.
Tank will only have the elevation of the tank and the dimension of the tanks.
All right.
I have a question. Pump. By adding the, I said, okay, use pump curve 1, but how do I know that actually the system was eating it? Let me put it this way.
The system is doing what?
Like the system took this pump curve I was telling the system to use.
Because you came here and you double click the pump property and you say pump curve 1. And so the system is obliged to use the pump curve 1. Without that, it will not run. You must go and define the pump by putting in the parameters of the pump. So if I use pump, if I create a new pump now, I'll call it pump 2. Okay, let me show you now. Let me create a new pump. Let me create a new pump and call it pump 2. And I'll give it a head of 100 and a flow of 600. I'll click OK. I'll double click on this pump and I'll say 2. Okay, let me try to run. Okay, it's giving me 100. I'm surprised it's running 830. Pump curve 2. Okay, let me edit the pump curve. Edit. I'll say curve pump head 50. Oh, it's running because, okay, I understand why it run, but 50 will not run. I'm sure about that. Unsuccessful. Robert, I didn't know if you understand it now. I put a very low
I
head.
understand it's
When
okay.
I put
It's
100
basically
and it will give me a report like this. You tell me pump 1 close because cannot deliver head. Cannot deliver head. So I'll delete.
So the implication is that you can create multiple pump curves so that you can test which particular pump curve you're supposed to pump is supposed to need. In this case now,
but that would be dangerous.
The one that has 50 head is supposed to be the normal that's required, because that means 150 was too much.
Thank you. It means that 100 can drive it. 100 pump, 100 head can drive it. You're right. But I always say this, as engineers, design for worst case scenario. There's no way. Yeah, design for worst case scenario.
10-inch.
Design for worst case scenario. 1 minute. So I'm waiting for more people. So let me give others 2 minutes to run and tell me whether they're successful. So if yours is successful, can you just chat successful for me, please? Okay, Prince is successful. Joshua is successful. Who again? Lega is successful. 3 people are successful. That's quite abysmal. I'm sorry. I need 2 more people, then we'll continue. So I'm going to give you 2 minutes. Okay, successful on first run. Good. Coyote successful. Okay. So Robert successful. Okay, now we are good. I have like 50% successful, so I can continue. Now, if you look up here, you will see that this says day 1, 12 a.m. So this is what we call instantaneous running. Now, I have done my model. So this is running at this hour. But in modeling, we have to simulate this design now. We have to simulate the design over a period of time. We'll simulate this design over a period of time and then see whether it will maintain the same success. So what I'm going to do now is to create what we call pattern, demand pattern. All of us will agree with me that in a 24 hours, the patterns are not the same. Yesterday, 2 days ago, I told us about pattern, rural pattern, urban pattern, and what do you call it? Semi-urban pattern. The daily pattern usually looks like this. Let me clean some things. So if this is 24 hours, this is 24 hours. In the morning, this is 0. This is say 12. And this is say 24. Water demand pattern in a rural area is usually comes like this. In the night, it's very small. Then at 6 a.m., it will spike. Around 12, it will come down. Then towards evening, around 8 o'clock, it will spike again, and it will come down. Then this is for rural areas. For urban areas, in the night, it will be like this because people are partying. Some people don't sleep at night in urban area. They party all night. Then in the morning, they wake up, they take their bath, they go to work. In the afternoon, nothing much happens, it maintains. In the evening, they're all home, it spikes. Then around 10 o'clock, they are sleeping. It continues here. So demand patterns are not the same. Maybe between here and 6 o'clock, the pressure on the network might be say 0.5, maybe 50%, sorry. Maybe you have only 50% of water consumption. In the morning, around 7 a.m. in the morning, when everybody is going to work, Abuja civil servants is around 9 or 8 o'clock, peak period. The water will exceed the design. The water will be, let's say, 130% of the design value. Then in the afternoon, the design will be normal, which is 100%. Then in the evening again, it will spike to say 120%. Then in the night, it will come down to another 50%. This is what we call demand pattern. So because this software is for modeling, we are going to do a model by creating a pattern. What is modeling? Modeling is your ability to predict, to use your data, what you have today, and predict the future. So now we have done our design, successful, pipe sizes are okay, everything is working. But we'll ask ourselves, how about if the peak period changes, if the population in Wuse changes, if the population in VI changes, to say there's an increase in 30% of demand on the network, how will the system behave? How will the system react? So we are going to create a pattern. Number 2, when we create this pattern, we are going to simulate it over a 3-day period or 72 hours period. You can simulate for 24 hours, 48 hours, 72 hours. In developed countries, when you drill a borehole, or even in Nigeria, you need to do what they call pump testing. You need to extract water at a defined rate for a 24 hours period. And you monitor the drawdown of the well. If the drawdown well, after plotting the drawdown well with the extraction rate, you can design the limit to set the pump. Then you can also define the properties of the aquifer to say, okay, this aquifer has a good recharge rate. This aquifer is sustainable. Because what most people do is that when you do your borehole, within 2 hours, the water is gone and the water aquifer is dry. So you need to calibrate your pump. You need to calibrate the suction to make sure that the rate of extraction does not exceed the rate of recharge. And that is what pump testing does for you. But in water reticulation, we call that pattern, demand pattern. So we're going to create a demand pattern. So to create a demand pattern, the first thing you do is, my screen is no longer being shared. Just hold on. Just stay with me. Okay, so I'll go to my browser again and I'll click on pattern. There's a place called patterns. And so if you click pattern, it will be empty. I'll add pattern. Pattern ID is 1. I'm going to create a 24 hours pattern. And it will be 6 hourly. Somebody say 6 hourly pattern. In other words, the water will change every 6 hours. 6 hourly pattern means I'm going to have 4 peaks because there are 24 hours in a day. If you divide it by 6, you're going to have 4 segments. The 4 segments is, meanwhile, if you want to see what I'm doing here, you go to the design manual and go to here, page 6. Page 6. I'm on page 6. So I will come here. Here will be first, between the hour of 6, between the hour of midnight and 6 in the morning, my water demand will be at 50%. Between the hour of 6 in the morning to, let's say, 12 in the afternoon, my demand pattern will be at 30% more, which is 130. In the afternoon, my demand pattern will remain at 1. In the night, around 7 o'clock, my demand pattern will go to 1.2. This is the first 6 hours. Everybody's sleeping. People only need water to flush toilets. Nobody's bathing, nobody's washing, nobody's cooking. But in the morning hours, rush hour, there's a 30% increase. Then in the afternoon, some have gone to work, some are returning to school. So it depends on the region, it depends on the city, depends on rural, urban, semi-urban. This demand pattern can change, but this is a typical demand pattern for an urban dweller. This is how it happens.
Excuse me.
Yes.
But I understand, but if you do 1, 2, 3, 4, doesn't it mean you just made it for 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock? Because
No.
we have 24 hours here.
Okay. In the next section, I'll define it to the system that what I mean here is 6 hours, 6 hours, 6 hours, 6 hours. And then there's no way you can say that the pattern changes every 1 hour. It's not possible. So it's a block pattern. There's no way you can say the pattern changes every 1 hour, the water usage changes. There's a spike. Negative or positive, it's not possible. So you create them 2 blocks in a 24 hours period. It could be 2 peaks, it could be 4 peaks, it could be 1 peak. 1 peak is possible. If it is 1 peak, then there's no need to create pattern. We don't have to do this. Okay.
So you, hello, sir.
Yes.
The pattern ID is that where you insert 6.
No, I'm coming for that.
We
So
have
I'll show you. I'll show you. We're not getting that. I'll show you where to put the 6.
No, we need to get this one that you have already for us to follow.
Okay.
This one that's on the screen.
Okay, can everybody do this now? Just do this and click OK. 1 minute, not more than 1 minute.
How did you get here now? That's what we're asking, sir.
How about some of us that our analysis didn't run? It was unsuccessful. How can
it's giving you, okay, if your analysis didn't run, what did it tell you? What did it write? What is the feedback?
It told me that there is an issue with my tank level.
Good. Go to tank level. Go to tank level now. Okay. What other issue? Can you put this in your tank level? Can you put 830 as elevation?
Yes, that's what I used. Can you
put 4? Can you put 4? 4 initial level. 1 minimum level. 20 maximum level.
Yes. Everybody has the issue with the tanker.
Yes, that's what I did, and it still told me that's what I have here.
Can you check whether there are 2 tanks here? By going to tanks and making sure there's only 1 tank.
It's only 1 tank. Tank ID, tank 1.
Can you go to the browser and click on tank and make sure only 1 tank is here?
That's where I am. It's 1
okay,
tank.
Can you click on this pipe and just this node and draw it up and make sure nothing is hidden, nothing is somewhere there.
Okay.
Please check your tank. You must have created 2 tanks that are superimposing. Go to tank and make sure it's only 1 tank I show you. Make sure it's only 1. Look at my browser. Make sure only 1 tank is here.
Excuse me, in real life conditions, how can we get this kind of pattern can we only do this based on an assumption, or is there any chance of actually getting this data?
It's by study, sir. Reconnaissance survey, your inception report, you take data, you look at the lifestyle, the area. I'm tempted to go to Google and do something, but I don't know if time will permit me for that, because I need to finish this today. So your demand pattern, you need to know, is this a rural area? Is it an urban area? What is the activity lifestyle of the people? If it's a rural area, in the morning by 5 o'clock, everybody goes to the farm. And before they go to the farm, they need to fetch water, they need to drink water, they need to bathe water, they need to cook some food. So there's a spike. In a university setting, please, between 5 o'clock and 8 o'clock, before they go to lectures, there's usually a spike. I remember those days in my university photo. If you don't come out by 6 o'clock in the morning, you're not going to see water by 7 o'clock. Because everybody just have lectures by 8 o'clock. And you see the queue, and suddenly you see that the water will not even run again. Hostel A has water, Hostel B doesn't have water. Why? Because the designers didn't factor in the issue of peakness. The same thing applies to road design. If you are doing a road, you must look at the peak hour. When you're talking about the number of vehicles that apply this road, it's not just in normal hours. You look at the peak period. That is what defines the boundary condition of your design. You have to look at the peak period and say, okay, this is when I know that this road is under the highest level of stress. So my parameters must be based on those key peak periods. In infrastructure design, we design based on peak values. Last week, I did a training on sewer and stormwater. We also talked about peak value. Because as engineers, our job is to design based on worst case scenario. So the demand pattern is something you do a study. You go and look at the people, look at the environment. Is it a school setting? Is it an industry? If it's an industry, do they do night work? If they don't do night work, then the demand at the night time will be 20%. You just can't say 10% because there are security men working in the factory. Then in the morning hours, when they resume work and then break time, you look at those time. That is when you design your system. So have you gotten it? Lucy, have you gotten or is it Ezugu that's asking? I know we have 2 ladies here. Have you gotten your run?
Yeah, it's still giving me the same thing. Invalid lower and upper levels for tank.
Can you go and put 830 for?
That's what I did. I have, yes.
I'm pretty sure it's not what you have. Just check again, please. Then you must have put some values here that I didn't define. Can you go down and make sure that you didn't put anything here?
Okay. I'll go down and check.
Okay. Those of us that have done, have you done your demand, your pattern? Go to tank and go to pattern. Have you designed your pattern? Please say yes if you have done it, please. Say yes. Just type yes for me.
Okay, so if your own didn't run, this pattern will not work.
It will not work, of course. It won't give you a good results. Please, gentlemen and ladies, just make sure that 2 parameters are in the node, 2 parameters are in the pipe. Nothing in the world will make it not to run. Because this is a predetermined exercise. So it has been calibrated to run. So if it doesn't run, something is wrong from your end.
Mine is not running. So I'm hoping that maybe later in the
Sir,
night I will
reservoir, what's your
reservoir
elevation? What's your reservoir elevation? What report is he giving you? When it did not run, there's a screen that comes up. Can you read what he's saying?
It told me that my pump or something was wrong with my pump.
Then your pump has a problem. So what you do now, you click the pump and make sure that 1 is here. That means you didn't define the pump curve well. The good thing about the software that it will tell you where you are getting it wrong. And it's just cool. It's just cool to tell you, this is your point, this is your problem. Can you go and work on it?
And maybe since we are going to get the recording, I can run it again later at night.
Yes, that is it. That's my plan also.
But if it doesn't run, can we private chat you on WhatsApp? Maybe tomorrow or Monday. So you respond at your own time.
I want you to run, please. Just while we are working on the other one, can you just make sure that you have 2 parameters in the node and 2 parameters in the pump? And if it doesn't run, is he giving you 2 reports? Is he giving 2? Is the only 1 report is giving you? Or
no,
2?
he's giving me 2 reports.
What is the second one?
Mine is it.
Okay, the second report is giving me is 1 or more errors in input file.
Yeah, the same thing is giving me also.
Okay, the input file, the second report, the second thing is referring to the first. So what it means is that your pattern for engineer Richard, there's a problem with your pump. So work on the pump and work on the pump curve. Just go there, go through chapter. Okay, very simple. 2 of you should go to, thank you. For you, Richard, go to page 5. Then the other lady, go to page 4. Here, look at it very well, page 4. You will solve it while we continue. Yeah. The input error I'm getting, curve 1 contains illegal numeric value. Okay, you have put something that I didn't put. Please go back to your pump curve. Only put in the parameters of the curve, please. Go back to your pump curve. This is curve. This is it. Please look at 600 and 150. Those are the only 2 things. No, now, pardon me if I say this. Sometimes there are default values. Don't touch them. What you don't know, don't touch it. Don't try something. Don't try something. No, just do what it has been asked. You have been asked to do.
600 and 150. Then we okay it.
And make sure that 1 is here. You okay it. Then you now click on your pump and say,
okay, on the curve ID should be 1, Abi.
Yes, and then 1 should be here. And the next thing you have done is that you must have created your pump back and forth. Your pump, delete the pump, make it from reservoir to 0.1. Okay, so now we've created a pattern. Now, for those who have created their pattern, the next thing we're going to do is we're going to simulate. So to simulate, go to options. Watch me now. I'll go to options. Under options, I'll fix the times.
Share your screen, please.
Oh, cool. So I'll go to here, my data view. I'll go to options. Why am I going to options? I want to set the option of my running. I want to simulate the network now. So in simulating the network, the curve is not generated. I don't understand you. Go to curves. Go to curves under data. Go to curve, you see the curve. Go to page 6. Read page 6, sir. You will get it. So
we cannot see your screen, sir. We just see your handsome appearance.
I'm seeing it here.
Refresh your own, sir.
Okay. Thank you.
Okay. Now, some of you asked me a question. We created a pattern and we say 6 hourly pattern. And we put in for 6 hours. So now we're going to go to times. Go to options. Go to times. And then you go to click on times. Dialog box will open. It will ask you, how long do you want to run this simulation? I want you to put 48 hours or 72 hours. What's in our table? It will ask you pattern time step, the fourth column, pattern time step. I will put 6 here. So this is how I put my 6. Or 6, 0 minutes. Because here it says hours and minutes. So I'll put 6. Don't change any other thing. Only 2 things I've changed here. Pattern start time, it will start at 00, which is 12 midnight. Every 1 hour, it will give you a report. When will the clock start? 12 a.m. I only changed 2 things here. I told him to run this pattern for 22 hours. And I told him that he should know that the pattern step time is 6 hours. So can you do this?
It's done, please. Can you continue?
Okay. So if it's done, just chat me, say done. It helps me to coordinate to make sure I'm not too fast. If you have done the pattern and you've done the timing, thank you. 72 hours and 6 hours. That's the only thing I change. Hydraulic step time, leave it at 1 hour. Quality time step is not our business. We're not doing quality analysis. 4 people, 5 people. So after doing that, you now enter. Remember, if you put any value, you press enter. When you are done, you close it. Okay. So remember again, you go to pattern. Something comes out like this. So you make sure that 1 is here. I don't know what you mean by Miriam. You don't know what you mean by system is down. 1 here, then 0.5, 1.3, 1.0, 1.2. Then you click OK. Okay. Take note of that. Then for the pattern, after creating the pattern, we go to options, go to times, and set the simulation time. Those are the only 2 things we have done. If I have wanted, I can also go back to hydraulics and make sure that everything is in place the way I want it. Gallon per minute, Hezin Williams, specific gravity is 1, relative velocity is 1. If unbalanced, continue to iterate, and everything. Default pattern is 1. It's only 1 pattern I created. This is just to confirm that everything is in order. So these are the only 2 things we are doing. We're not doing energy analysis. Energy analysis, I'll go and do my energy analysis for the pump, but I don't think I need to do that. The efficiency of the pump is 75%. The price is not indicated, so I'm not doing pricing. I'm not doing energy consumption. But these are things you can also play around with your own to get more value for your network. So when I'm done, I will go to map view. Somebody go to map view. Okay, I'll run. I will run. Mine is successful. Can we run and see if it's successful? What this means is that even if I increase my network by 30%, my network is capable to take it. That's what this thing means. So network is successful. So those that have finished, can you run again? After creating a pattern, run again to see if the pattern you created is sustainable. Successful, successful. I've seen 2 successful. 3 successful. I need 1 more. Okay, Robert, successful. Okay, so we have I have one. I need 1 more successful. Those that have run, need 1 more. Again, this is pattern. You create your pattern on page 6. You go to times, options, times, 72 hours, 6 hours. So I'm going to view result now. I'm going to view my result now. So to view my result, I go to map view. Okay, 6 people have done successful. So I'll go to map view. So click on map view. This is map. Yes.
Sorry, I'm lost.
Where did you get lost? Let's know where to find you.
Okay, so what we've just done now. Okay, so you clicked on time, right?
Have you created your pattern?
I've not created a pattern.
Okay, come here, click on pattern. You see new. You click on new. Okay. The dialog box will open like this. You put 0.5. You put 1.3.
Okay.
Which is 30% more. You put 1.0 normal. Then 1.2.
I go to time, right?
No, pattern. First of all, create a pattern.
Okay. Pattern.
Yeah. Then you click new. You click this small icon. Add new. Then you put in these values.
It didn't come out for me.
Here. Click here. Click this. Click this small icon here.
Okay, at the bottom.
Yes, at the bottom, sir.
Okay. 1 minute, please. Yes. Okay.
You put those values. See the values here on your screen.
Number 1 is
0.5, 1.3,
0.5,
1.3, 1.0.
Sorry, it doesn't. 0.5. Okay. 1.3.
1.3, 1.0.
1.0.
And 1.2. And make sure that the ID is here is 1.
1.2.
Make sure the ID here is 1.
Is 1.
The ID pattern, the pattern ID. Because you're going to do the same thing you did with your, you're going to do the same thing we did with your pump. So you're going to reference that I'm using ID pattern 1.
Yes, I've done it. I've put them in.
Please make sure the pattern here is 1, then click OK.
Okay. Okay, what next?
Now go to the same data view, go to options. Under options, you go to times.
Okay.
Change the duration to 72 hours. And the pattern, the 4th one now, pattern time step, 6 hours. Pattern time step, 6.
6.
Pattern time step, the 4th one, sir. The pattern time step.
I've changed it.
Okay. Duration 72.
Okay. The duration.
Pattern time step 72. The pattern time step is 6. Watch, see my screen, sir.
I can't see duration.
Can you see my screen, sir? Duration is the first one. Scroll up.
Okay. Total duration.
72.
22.
Watch my screen. 72. Pattern time step, 6 hours. The 4th column, number 4 column. The 4th row.
Okay.
6 hours. 6.
I've done that.
Pattern time step. I say it again. Pattern time step. Then leave the rest.
I've done it.
Okay, good. The next thing you do is you run.
Okay.
Was it successful?
I'll go to run. Unsuccessful.
Eh?
Not successful.
Was the first one successful?
I didn't run the
Okay. You draw us back. So what you do, the video is there, eh? But what you do while you are waiting for us, can you click on your nodes and make sure that two parameters, elevation and demand, are in all of them? Then you click on your pipe and make sure that the pipe has the length and the diameter based on what is on page 6, based on what's on page 5.
Okay, I'll do that.
Good.
Thank you.
Thank you, sir. So now we have run the pattern. The next thing we do is we're going to view our results. So let me view, go to map view, go to map. Still continue, sir. Engineer Antonio, just continue. Later you just get it right. Don't worry.
No
This
problem.
is no big deal. Go to map. Somebody raise his hand. Ask your question, please. Elijah. Uchimana. Okay. Go to map view. When you get to map view, you can choose two parameters to view. For instance, I want to choose my base demand, see my base demand and my velocity. So I will view it and check where the velocity is low, where it is high, where it's below value. So this is the velocity of the system at this hour, 12 a.m. Now, because I have designed for 72 hours, under this time, if you click on it, you see that the time is from 1 to say 72. So I can virtually watch what is happening every 1 hour in my network. I can see what is happening in my network every 1 hour. So I will come here, I will click on this forward, like play. If I click play now, my system will run, just be watching it. It will run for the next 72 hours. If it's too fast, I'll drag this thing back, animation speed back. 14 hours, you're watching up here. This is day 1, 5 p.m., 6 p.m., 7 p.m.
Excuse me, I have one question. I see the color has changed from my knots, but the pipes are still, and now it shows NA not applicable, not applicable, not applicable for each pipe.
Okay, I know what you did now. Now what you do, you didn't choose, go to map, choose two parameters here.
I choose base demand and velocity. And then this kind of VCR style buttons, they are grayed out. I cannot use them.
Oh, because you didn't run your pattern. I understand. So go back and run your pattern. You didn't run your pattern first. And make sure your pattern was successful.
Run was successful.
Then now go to map.
Unsuccessful.
Good.
Jesus Christ.
So that's where the problem is.
Okay. All right. You can.
Hello.
Okay.
Hello.
Yeah, I can hear you, sir.
Yes. Mine is not showing the colors. I don't know.
Okay. What you do, sir? If you have run your pattern, if you have created your pattern, what we're doing now is what they call simulate. We are simulating the design. We have modeled it based on the design pattern. So we are simulating it over a period of 72 hours.
Maybe did you use dot or comma? Dot.
No, dot.
Okay.
Yeah. Oh, 6 hours. Yeah, go back to your, I know where the problem is. Oh, and please go back to your options, times. So under this pattern time step, just put 6. Don't need to put anything. Don't need to put the minutes. Just put 6 only. Enter. It's okay.
Okay.
And 72 hours. And make sure 72 is here. I don't think you put 72. Maybe put 0. If you put 0, it will gray out because you're not running. You're not simulating over a period of time. So you must put 72 here.
Okay, run was successful. I got it now.
Good.
Yeah.
Good.
Okay, that was the one. Thanks.
Then after that, you now go to options, and then you, after running, you now go to map view. Map view. You go to map view. You now choose 2 parameters you want to view. Then you click this forward. So this will be moving. So remember, this is 3 days. So this is day 1. So these are the parameters. If it's too fast, you reduce this bar.
Yeah.
So I'll click stop. Yeah, good. I'll click stop. There's no need. This is just to show you what is possible. The color means anything. Yes, the color means something. Based on this legend, you can go to this color legend and set your parameters and set what like this. This is this now. If I right click on it, it will give me the color pattern and the values. So I can come here now and set and say reverse color. If I say reverse color, I'll come here and say when the pattern, when the flow is less than 0.1, I'm giving an instant velocity, give me red color. And when it is more than 5, give me a blue color. So the pattern, the color now shows, whenever I see a red color, I will know there's danger based on my pipe. So you see, there's a danger here and there's a danger here. But these ones, I'm not bothered about this because it's a pump. So here, I will permit this because this is a tank. At some point, the color goes out. So I cannot be able to go into that because we need to end this class in the next 25 minutes. So here you can go and change your legend by right-clicking on it, and then you can play around with it. You can change the color ramp to any color of your choice. Okay. You can change the color ramp. You can reverse it. You can change the upper and the lower limits. The idea is that from a glance, I can see the pattern. I can see some of the pattern. I can know where the problem is. And let's say I'm looking for where the head is. This color is not looking good. No, 9. This color is bad. So I'll maintain the rainbow color. Good. So I can come here and say, can I know all my elevation and flow? Okay. This is not making too much sense for me. I'm saying that the elevations are should be red. We all know that the elevation of most of the nodes are around some 100. So it's not a good parameter to measure. So I'll remove elevation and I'll go to pressure. So here, anywhere the pressure is more than 10 bars, which is 100, it should indicate red. So you can see that the pressures are not more than 10 bars. So that's why none of the nodes are giving red color. None of the rows are giving red color. If the pressure goes above 100 psi, it will indicate red. The same thing with the flow. The flows are all okay because the flow is up to 250. So here I'll change it to say 1000, for instance, and say when it is below 400, when it is below 200, and when it is below 100. So I won't see red again because I've increased the upper limits. So the red only means something to the extent that you define it. So you are the one to define what the color means. You have to go and define what the color means. Now let's go to report. This is nothing. This is not a big deal. This is just for you to see that you can screenshot. You can screenshot any of this and paste it to your report. But then you have to screenshot 72 times because every 1 hour is giving you a report. So all you need to do is probably you go and screenshot those critical areas. Those areas, good, you got it. That's good. Green does not mean okay, red does not mean okay. It's you that will define it. What means what? It's you that will define the color gradation. It's you that will define it. Whether you want your red to mean negative. Some people red means danger. Some people red means red flag, sort of. So it's you that will go and define it yourself. How do you get to legend editor? Legend editor comes out, but if your own is lost, go to view, go to the legend, and then you click on it. Okay, legend editor, right click on it, sorry. Right click on it this way. I click on the legend, you edit it. Right click on it, you edit it. Right click on it, you edit it. Right click on it, you edit it. Right click on it. How do you get the node pressures? The node pressures is, I go here under map. I make sure that under the node, pressure is indicated. But this is not the big deal. The big deal will come, where the big deal will come will be in my table reports.
Hello, Che. Hello.
Yes.
Okay, just one question. Can you hear me?
I can hear you.
Okay, the question is not for you, it's for the participants. I want to really see who among them can really answer the question. Then before you go to the main report for you have really tried, very excellent this thing. The question I want to ask the participants, you just created a pattern now. What is the relevance of this pattern in your hydraulic modeling? What are you trying to achieve by patterning your network? Is there any of the participants who can answer that question?
We consider a peak. Consideration of a peak flow hours.
We want to refer it to the first day lecture, whether you people are really follow. So why is it relevant to you? What do you want to achieve by doing this patterning? You can run it without pattern, but why is this pattern relevant for you? Okay, so that my colleague can proceed very fast. You remember on the first day we talked about equalization volume when we are trying to size the tank. You remember? Do you still remember? We talk about equalization volume on the first day when we are sizing the tank. Yes. So this pattern, you know, but who is making that noise?
Let me mute them. Then you unmute yourself again. Go ahead.
Let me unmute. You remember that day we have two curves where we have the inflow curve and we have the outflow curve. So when we take the maximum difference between the inflow and the outflow, we were having a value of that day where we were having 15 cubic meter and 170 cubic meter that very day. So that is the equalization volume. So this pattern you just did helps you to achieve that outflow curve that look like S curve. So is this pattern that helps you to achieve that. If you don't perform this pattern, you will not be able to get that outflow curve. So that is the main reason why you are patterning this your network. So thank you very much, Uche. You can proceed to the main report.
Okay, thank you so much, Engineer Sunday.
Please, a quick one. Do we have Engineer Sunday's material among the materials you gave us?
Is the Engineer Sunday?
Yes.
Okay, Engineer Sunday.
Yes. Hello.
Can you send the PowerPoint you presented to the chat box? Somebody's asking for it.
But I'm on the roads. I'm using phone. Maybe I will share to you. You share to your mails.
Okay.
Okay. Thank you very much, sir.
Okay. Okay. So now, the next thing we're going to do now is to create a report, and this report is one of the big outputs of Epanet. Now, for the procedures and everything we have done, when you review these things, you understand them. There's no big deal about them. The videos are there, and when you watch the videos, you're going to definitely going to catch up. There's no big deal about it. The next thing we're going to do is to report. There are different reports you can do. The quickest report you can do here. Okay, let me stop this. I will stop it first. Good. I will go to table report here, or let me just use the report menu. If you go to the report menu, there are many reports you can give. If you are doing energy, you can give energy reports, status reports, full reports, table and graph. So I'm going to dwell on full reports, graph, table. So let me start with full reports. Click on full reports. Watch me now. When you click on full reports, the system will generate a report. So I will save it on my desktop. So let me call it training day 1. Training day 1. So training day 1, I will just save it somewhere I know, please, on the desktop, on the folder. So this is training day 1. I'll say save. It has saved a report for me. So I will now go to my desktop. Stay with me. I'll go to my desktop and I will see training day 1. Look at it here. I will right click on it and open it with MS Word. Open with MS Word. Open with MS Word. Hold on, it's coming. So this is a report. So this report will give you is about 50-something pages. Why? Because it will be giving me hourly reports of my network. So every 1 hour for 72 hours, it will give me a report. What report is it giving me? This is my node, the start of the node, the end of the node, the diameter, the length will be there, the diameter will be there. Then the demand is there, the head loss is there, the pressure is there, the quality is there. We didn't define the quality. Okay. Then the flow.
I have a question. Excuse me. Is there can I see if the tank volume is correct? Because I should be able to see the fluctuations, and basically I should be able to see if my tank is maybe largely over dimensioned. I think it was blue all the time, so I think it's not under dimensioned.
No, but yes.
Is there somewhere where I can practically see it?
No, I think the tank volume is fixed, but what is changing is based on what you want to see in the tank. Is it the node? What you define? The tank is acting as a node, so the tank can only change color based on what is happening in the tank, the pressure at the tank, at that point. Yes. So it is not giving you whether it's over dimension or under dimension. It's you that will do that, but it will be giving you the pressure at the tank based on the height. You know, the tank has a height of 20 meters. So as the water is dropping down, the pressure is fluctuating.
Okay, but I think there is a maximum filling point, and if I still have above this water level filling point, still have always 10 meter or something like this, maybe then I could make the tank smaller, isn't it?
Yeah, it will give you the result based on the pressure. You know, the variation in the tank, level of water in the tank, is a variation of the pressure. Is a variation of the pressure. So the system is not going to tell you whether the tank is big or small, but it will tell you the pressure. So it's let me just say it's not too relevant. It is not too relevant, what's happening in the tank. Okay, for instance, look at my screen. The demand at the tank, the water level at the tank at that point is what the tank needs to get filled at 1 hour. At the first one, at the 1 o'clock, is about 229. And the head at that point is 234. And the pressure is not relevant actually. Then if you go further, I think if you study the report, you can get 1 or 2 things from it. I can't get it. Okay. At some other point, hold on. At the 5th hour, the demand at the tank is 216. So this is the volume of the tank somehow. Then the volume is not varying based on the water level. And this is reflected in the head. So just like you have reservoir, the major parameters of a reservoir is the head. The tank also is giving you the head of water in the reservoir. So with that, you can know when to start filling the tank. That's what this means. So to study the report, I think it's something I will leave to us. We can have our time. Okay, somebody said doesn't understand what I did in the pattern time step. Okay, let's talk about reports. Those of you who don't understand anything, I'll come back to you. So now, the second report we're going to see is a table report. This is table reports. If you click on table report, you go to the node. Let's go to the node. But before I go to the node, I would like to filter to indicate what I want. Here, I want to see the elevation. I want to see the base demand. I'm not interested in the quality. Okay. So this is for the whole node I have. This is what the report I have. You got it? Now, if I want to copy this to Excel, what I need to do is I'll come here in between the column and the row. I'll click here. It will highlight everything for me. I'll go to edit. I'll say copy to clipboard. Then I'll open an Excel file and I'll say paste. And then adjust it. Then of course I can come here and give the name and say nodes, node values. Enter. If I am looking at the, go back to table reports. This time around, I want to look at the pipe parameters. I'll click on this node, column. I'll say I want to see the length, the diameter of each pipe, the roughness, the velocity, the unit head loss, and maybe the frictional factor. I can define everything that I want to see. The reaction, no. The quality, no. The status, no. I'll say, okay. So these are the diameters of the pipes. These are the roughness. These are the flows. These are the velocities. These are the unit head. These are the frictional factor. So I can do a lot of this, especially in the academia. So I'll click here in between here again. I'll go to edit. I'll say copy to clipboard. Okay. I'll go to Excel and I'll click a new sheet. I will paste it. Why do I need this? I think with this, I can do my costing. Why? Because I can come here. I can come here and I'll say total pipe length. I'll come here and I'll say auto sum. Enter. I need a total of 38,000 feet of pipes. But these pipes are in different diameters. So I need to filter. So I can filter. I can come here again and say, 14-inch pipe. How many of them? 12-inch pipe. I can say 8-inch pipe. This thing I'm doing now is not Excel property. So if I want to do that, what I'll do, I'll come under here. I'll click on all the pipe size. I'll go to Excel. I'll say filter. I'll come here and I'll say filter all the 8 inches pipe. So these are the 8 inches pipe I have. So I can say length of 8 inches pipe is equal to, we'll come here and say equal to sum brackets. Enter. Okay, I'll come out here again. I'll deselect all. I'll say all the 6 inches pipe. Give me all the 6 inches pipe. So I'll say here, copy this, paste this. I'll come here, equals to sum. Sorry. Oh, sorry, this is CG, sorry. I'm just trying to tell you what you can do when you copy the results and put them in Excel. You can perform cell operations that will be useful for you. Why is it giving me this? I don't understand why it's giving me this. I sum these two together.
It's summing every other cells that are between.
Okay.
Just check your formula. Yeah.
Okay, then I'll say equal to. Okay. So I'm just trying to. So assuming that this is 1,000 pipes, you know, I can do a lot. I can isolate. I can isolate them. So 10 inches pipe is only 7,000 in so 7 inches is only this. Sorry. So remember what I did again? I went here. I said, give me table reports. I said, I want the pipe, and I indicated all the things I need. It can give me more. It can give me a lot of things, but I need to filter the ones I don't know, the ones I don't need. In fact, if I want there, I will just remove all the other ones. Since I'm interested in the pipe only, I'm not interested in the flow, but I'll just remove all these ones. Just say only one the diameters only, and this is it. And so I click in between here, in between the column and the row. I'll now click edit, copy, and now say okay. I will now go to Excel again, and then we are paste it. So back here, I'll go back and say clear filter. Get back to where I am. So you can see that the software is powerful, I must say. For the mere fact that it can help you to do costing is enough tool on its own. Then the fact that it can help you to simulate and run your patterns is something. So the other things that you can do with this software, please, I'm leaving it for us.
Please, can you touch on the graph, please? Okay.
Okay, the graph now. I don't too much use the graph because in the consultancy world, what do you want to do? It's the academic world. So let's say contour plots or profile plots. Okay, what you need to do is to add the nodes they want to plot. Let's say I want to plot this node. I'll say add to come here. All the nodes I want to plot, I'll say add. End of the day, I'll plot it to give me the pressure movement between that node and that one. Now for the graph, there's a whole lot you can do it, but I can tell you this is for academics. Because as a consultant, you don't go design Epanet and you start showing people plots and time series. There are many things you can plot. There's so much. But I will humbly and respectfully refer you to the manual. Refer you to the manual. Somebody says, I don't understand what you did in the pattern aspect. Okay, what I did was under the data view, I came here, I did pattern. I said for the first 6 hours, people are sleeping. The network will perform at 50%. This thing is what my colleague said, Sunday said. You do demand pattern, and Robert also asked me the same question. You see, ladies and gentlemen, in ideal case, when you want to do a design for a district, you should submit your inception reports. You are supposed to visit the sites, collect your data, do interviews, do aerial data, collect data from urban development, ask questions. What was this place designed for? What industries are going to be built here? what kind of people are living here. That will inform the parameters you use for your design. So reconnaissance survey, reconnaissance survey. So it is from there that you build this. And let me also say this, as a design consultant, nothing is cast on stone. If I type now, what is the design pattern of Oklahoma? Don't be surprised, you see 100 reports, results comes out. Can we try it? So these are the things you use to build this your design pattern. So the only technical thing I did was, after building my pattern, which is a 6-hourly pattern, I make sure that pattern ID is 1. Then after this, I now went to options, times, and put in 6-hourly here, and then simulated for 72 hours. That is only 2 magic I did. For those of you who your own didn't run, I will tell you where your problem is from. From tomorrow, from yesterday, we said that if you want to design every network, you need 4 parameters. And in these tutorials, these 4 parameters were given to us. Our job is to key them in. Some of us have not keyed them in. Some of us have made mistakes. Some of us have drawn double network. The length and the diameter. If you take your time and go through this and key them in very well, it will run. Why? Because this thing has been, the result has been concluded. So it's not like we are trying whether it will run or it will not run. No, it's a pre-documented proposed tutorial already. So somebody have run it before, somebody have used it somewhere and it run. The next thing I wanted to show us, which I'm going to show us in the video, please go to my video and watch it, is how to import background and scale them. Let me show you something. Yesterday, we did a design on this. So let's assume that I was given this to design. You see how I'm going to import it now. If you watch my, for the next, instead of keeping us 1 hour, now, I'm going to share a video of what we're supposed to do in the next 1 hour. And you do it and you will get it. You will get it. Now, if I want to use this as a background for my Epanet, what I'll do is I will come here. I'll go to take a snapshot. Because the thing is in PDF. If it's in JPEG, I don't have a problem. But I need to convert it to JPEG first. I will snap it. I will come to my task bar. I will put in paint. Sorry, I'm going to stop this report, this lecture, because this what I'm doing here has been recorded already. No need to record.